Yeah, thanks on everyone. Let's start off. Sure, others comes on. Let's start off with a problem. We have a conveyor belt here. Which is moving with a constant speed of 10 meters per second. L is the length of the conveyor belt. And from here, the height of this thing is 80 centimeters. So the belt is continuously moving with a speed of 10 meters per second. Coefficient of friction is 0.2. Someone took a block of mass m and placed it at rest. Length of the belt is L. So what will happen? This block will start sliding, and eventually this block will fall on the ground. This is the range. Find the range. M and L values are not given. Hope the question was clear. What will be the direction of friction on the block? Start from there. Try. I'll give 2 minutes, then we will see. So how is the direction of friction? Ask yourself. Just look at the conveyor belt and look at the block. If you look at the block is at rest initially, whereas the conveyor belt is going forward. So there is a slipping. So what will the friction do? The friction will actually help the block. So if you draw the FBD of the block, the friction will be acting forward. Since it is slipping, friction is maximum, which is mu mg. So if you actually check the FBD, this is how it would look.
Sir, how
Yeah.
about friction is acting forward?
So what is the job of friction?
Sir, to oppose motion, right?
It is opposed motion. That's what you studied. Or is it to oppose relative motion?
Yes, sir, opposite to sir.
And then, so what is the relative motion here? The floor is going forward, the block is not moving. So what are you supposed to do? You have to keep them together.
Yes, sir.
Yeah. So friction will actually act opposite to this thing. But since the belts are run with some machines, the speed is maintained. Are you getting it? Technically speaking, the belts would slow down. But there are some machines, so that is the thing there. So what is the acceleration then? F max is equal to ma. Mu mg is equal to ma. Mm cancels, we get a is equal to mu g. Mu is 0.2. That becomes 2 meter per second square. So this block accelerates with a speed of 2 meters per second square. Here, then what will happen? Now here, this is where a small issue is there. I think Arya and Samyak, you got the idea there. So when you kept the block here, your initial speed is 0, but your acceleration is 2 meter per second square. So eventually when the block reaches the other end, let the velocity be v and the length is L. Since acceleration is constant, I can use the kinematics equations. V square minus u square is equal to 2as. V square 0, acceleration is 2, and this is equal to L. So from here we get v is equal to 2 root L. So this is the speed when it reaches the end of the conveyor belt. But there's a small problem. What happens if the speed v becomes equal to 10? Tell me one thing. What is the job of a friction? It is to make sure both of them go together, isn't it? So if the speed v is equal to 2 root L, if v becomes equal to 10 meters per second, what will happen at that instant? Friction becomes 0. So this block speed can't keep increasing forever. The maximum speed the block can reach is 10 meters per second, the speed of the conveyor belt. Since the slipping stopped. Are you getting what is happening? Initially, block ka speed was 0, conveyor belt ka floor ka speed was 10. And friction is saying, boss, I want to keep both of you together. So friction is acting forward. The block ka speed is increasing 1, 2, 5, 6, 8, 9. The moment it reaches 10, block ka speed is 10, conveyor belt ka speed is 10. There is no relative motion. Right, Advay? So once both the block and the conveyor belt get the same speed, there's no relative motion. If there's no relative motion, what is your job as a friction? To keep them together, and they are together. So stop acting, right? So slipping stops. You have done your job. You made sure both are going together. So this is the catch. That means this value which you have, v is equal to 2 root L. When this becomes 10 meters per second, so there is a limitation on the length of the thing. So L will be 25 meters. That means if the length of the conveyor belt exceeds 25 meters, the speed cannot increase. It will remain constant at 10. So what speed you get will actually depend on length of the conveyor belt. That's the reason I didn't give you that. For example, in the exam, if they give you L is equal to 100 meter, if you put V is equal to 2 root 100 and write 20 meters per second, that's a wrong answer. Are you getting it? So the friction will act only for the first 25 meters and remaining 75 meters, it will just go with a constant speed. Is this making sense? So your speed will be this. Your speed will be 2 root L for length less than 25 meters. Your speed becomes 10 meters per second, a constant speed for length greater than 25 meters. You actually get two different things. So what speed you get will depend on the length of the conveyor belt. Any doubts on this page? All clear why the block will stop, friction will stop acting after 25 meters. Once the speed of the block and the conveyor belt becomes equal, the slipping has stopped. If both have same velocity, there is no relative motion. There is no need for friction to come. Clear with this? Then, so the block is flying from here. It goes and falls on the ground. This height is 80 centimeters. This has become projectile motion, throwing from a building. What is the time of flight? The time of flight is root over 2h by g. Hope you remember. This will be 2, h will be 0.8 meters by g is 10. That would be 0.16 or 0.4 seconds. So it will fall down on the 0.4 seconds. So what is range? Range will be horizontal velocity into time. So again, we have two answers. So range will be v into t, that will be 2 root L into t. That would be how much? 0.8 root L. This is the answer if length of the conveyor belt is less than 25 meters. 10 into 0.4 is 4 meters if length of the conveyor belt is greater than 25 meters. There. So what range you get will depend on the length. So examine what they'll do, they'll give L is equal to 100 and they'll ask you the range. What most people will do, they'll put L is equal to 100 in this, they'll get speed 20 meters per second and they'll get the answer. What most people don't realize, the slipping stopped at 25. The remaining 75 meters was useless. So if you actually try to plot a graph, I didn't ask you this, but if I can plot a graph, range versus length of the conveyor belt, the range will keep increasing with length till 25 meters. After 25 meters, the range becomes constant. This is how the graph looks. I can ask you that also. Plot range versus length of the conveyor belt ka graph. This value is 4 meters. Is this clear, everyone? So the main catch is this point here. At 10 meters per second, friction becomes 0 and the slipping stops. Any doubts on this? Let's see one more. Decent question. So that's it. It's a small trap. And most people think, friction will be backward. Friction won't be backward. Think about it. Next time when you get onto an escalator in a mall, how does the friction act on you? Escalator is going forward. The moment you stand on that, the friction acts forward on you. That's why you go with the escalator. If the friction acts backward, just think about it. If your friction acts backward, and this block here will fall backward, does it make any sense? If you get onto an escalator, you don't fall backward. You go with the escalator. So that is one. Let's see one more. Let's say we have a weird incline like this. So let's say we have a rope. It's a uniform rope. Of mass m. It's a rough surface, mu. This is h and this is L. So this is a rough incline and you kept a rope on it. So the uniform rope of mass m on this thing is on the verge of slipping. Meaning if you push it little, it will start sliding. That means friction is maximum. That is, it is about to slip. Find mu. Hope the question was clear. Anyone didn't get the picture, please ask me. So we got some weird incline. I don't know the shape. You kept a rope on top of it. It's a uniform rope. Mass is m. Length of the rope we don't know, but height of the incline is h, and the base is L. If you remember, we did something like this in NLM. So this rope is about to slip. Matlab frictions have become maximum everywhere. All you need is a little push, and this thing will slide off. If that is the scenario, find mu. Anyone not clear with the picture or the question, please ask. Question is clear. Go ahead. You got 2 minutes. So that is the meaning of verge of slipping. Hmm. Right, Arya. Let's see. H by L. Where is theta, right? रुद्रांश यहाँ पे तो theta है ही नहीं. Let's see. So consider a small part of the rope. Anywhere, you take a small piece here, ds. So you can treat it like a small incline. So what are the forces acting on this? If you look at the forces here, this will be dmg sine theta. Dm is the mass of that small piece. This would be dmg cos theta. Normal reaction. This will be friction on the small piece, df max. And actually, if you see now, there's also tensions also here. There will be some T1 and T2 also. We are not writing them for now. So the mass of small piece dm right? So you can write this thing as dm is nothing but total mass of this thing, total length of the rope, which is not given. So I'll just take it as L into ds. Let's not worry about that. L is the length of the rope. That is not given, but we have to cancel it out. Now look at this thing. So what is happening here on this entire rope? There are multiple frictions, isn't it? All these frictions, df, df, df. So at every point you have a friction df, and at every point the friction is changing because the normal reaction is changing because theta is changing. So all these frictions are pulling up. At the same time, at every point, there is also your dmg sine thetas. the weight ka tangential component dmg sine theta, dmg sine theta. Again, theta is changing. So all these points are pushing down. Making sense? So can I say like this? The total friction force must be equal to the total tangential forces. It is along the string basically. Total tangential forces along the rope. So all these frictions will balance all these dmg sine thetas together. So that means this will be integral df is equal to integral dmg sine theta. So far clear, everyone? So all these frictions will balance all these dmg sine thetas. Any doubts on this page? So once you got that, so df max will be dmg sine theta. Remember, theta is variable. So what is df max? Df max is nothing but friction mu into dn. But what is dn? Dn is nothing but dmg cos theta. So this will be mu dmg cos theta. This is dmg sine theta. And what is dm? Dm is nothing but total mass by total length into ds, the length of that small piece. How do we get that? Unitary method, right? Total length is mass m, then ds ka mass is how much? This will be mu. This is m by l g ds cos theta. This will be m by l g ds sine theta. Now that small piece which you have taken, this is ds. This is theta. This will be horizontal dx and this will be dy. So dx is nothing but ds cos theta. Dy is nothing but ds sine theta. So mu m by l mg will cancel on both the sides. This will be ds cos theta is equal to integral ds sine theta. I don't know ds, I don't know theta, but I know what is integral ds cos theta, integral dx. This will be integral dy. X ka coordinate goes from 0 to L and y ka coordinate goes from 0 to h. This will be mu into L is equal to h. Mu is equal to h by L. All that story that we did, meaning you got a result pretty neatly. It's a standard result. Do remember this. It's a standard model. That small L got cancelled on both the sides. This term and this term will get cancelled because they're constants anyway. Clear with this. Again, what we did, we took any random piece at some point, making an angle theta. So this small part will have df maximum acting upward and dmg sine theta acting downward. So all the frictions on the rope will balance all the dmg sine thetas. So we have to integrate them because they're changing at every point. And then when you integrate this, you end up with this. So a better way to remember the result. So I'll put it in a more standard form. Let's say if you have some weird shape like this. This is L. This is H2. This is H1. Let's say you have a rope like this. Again, rope on the verge of slipping. That is important. It should be on the verge of slipping. Why? If it is not on the verge of the slipping, you can't write this is F maximum. And if it is not maximum, you can't write mu into dn. You can't solve the problem. Rope is on the verge of the slipping and the friction is mu. So this is the result. So mu will be the difference in heights, h1 minus h2 by L. That's your result. So the difference between the two ends. by the horizontal distance. That will give you the formula. We can always write h1 minus h2 by L mu na. You can do that. This is the condition, right? So it will be less than this. Is this clear, everyone? So there, this is a more general form. You can take any weird surface, anything, doesn't matter, you'll get this. So if I have to ask you a question, how will they frame this? Let's see a question on this. Any doubts on this? All clear with this result? You have to remember this exam, you won't have time to derive this. You can, but yeah, you can see how it is. It's a little complex, but can be done. Let's see a question on this. Let's say we have a hemisphere. You kept a rope here. This angle is 30 degrees. This angle is 60 degrees. The rope is about to slip. So both the sides are not equal. This is mu. Find mu. There, instead of giving some weird shape, I gave a hemisphere this time. So you kept a rope such that one end is making 30 degrees with vertical, another end is making 60 degrees with the vertical. So if this rope is about to slip, meaning little push and the rope will slide, find the coefficient of friction. Right, Siddesh. Yeah, one answer, others. Srihari, you can simplify. Okay. Let's see. Same thing. Remember, it only depends on the height. So you are interested in this height. So if that is 30, this is 30. And that is radius r. So this will be r sine 30. This will be r cos 30. This is 60 degrees. This is r sine 60. This is r cos 60. So basically, this is the length L, the distance between them. This is your h2. This is your h1. So you're done, right? So mu is equal to the difference in height, which is r cos 30 minus r cos 60 by the horizontal distance between them, r sin 30 plus r sin 60. Are you able to see this thing now? This is the rope basically. Instead of that weird shape, this is how it looks. R gets cancelled everywhere. Cos 30 is root 3 minus 1 by root 3 plus 1. Yeah, you can do factorizing and all that stuff, but then you got an answer. Yeah, if you simplify that, you get 2 minus root 3. All clear with this? So you want the distance, horizontal distance between the ends and the difference in height between the two ends. Next one. Next one. This is another good one. We have a fixed rough cylinder. You took a rope here and you attached a block of mass M. On the other side, you have a force F. And the cylindrical friction is mu. So this is a massless rope. Let me just add some thickness. So we have a rope going over this. Remember, till now, all the problems we did, pulley was smooth and frictionless, frictionless when massless. But here there is a rough pulley, there is a friction mu. Find F if the block is at rest. Gravity is there. Pretty good one. Little different than what you have done so far.
Sir, you said the rope is massless, right?
Rope is massless.
Okay, sir.
Rope has no mass. What if we increase the bump on the beard and climb infinite height and make it down infinite length? See, as long as you make that statement now, it is on the verge of slipping. That is taken care of. What is the catch in this problem? What is the problem with this? Let's see first try to understand what is happening. Again, we have two cases. Let's say if you apply really a lot of force, there is a maximum range. We actually get a range of forces. Let's say if you take maximum F, that means you're pulling the rope so hard, the block will try to go up. So just look at the string. So if you look at the string here, when you're pulling this, and when the block is trying to go up, so the rope is actually turning like this, isn't it? How will the friction be? The friction will be in the opposite direction. So if this rope is trying to go up, See, you are rubbing the rough surface and you're going ahead. The rope is not, it is sliding on the rough thing, rough cylinder. So there'll be friction on the rope now. Because of this friction, you have to apply more than mg, isn't it? So you have an mg here and you have a friction now. The force will exceed mg. Is that making sense? So if you put this rope over a rough surface and if you're going to glide it, there is going to be friction between the rope and the cylinder. So this is the friction between the rope and cylinder. So this is the case when you have maximum force and the block tries to go up. The other case is a minimum force. Means if you don't apply enough force, the block will try to go down. And block tries to go up. If you apply very less force, the block will try to slide down. In this scenario, the block is trying to come down, and the rope is trying to move this way. If the rope is going that way, to stop the rope from going, you'll have friction this way now. So whichever way the rope is trying to go, the friction will be opposite to that. So in this case, you need to apply force less than mg. Are you getting this? So you get a range. As long as the force is between these two values, the block will be at rest. Now the headache is we have to calculate that friction. Let's see how to do that. This technique, what I'm teaching you, is important. This you'll again encounter in circular motion. You will again see this technique in at least 6 more times. So listen to this carefully. It will be a little different, but yeah, it's we can handle that. But did you get the idea what is happening? Why the answer is not mg? Because till now in all the problems you did, the rope was smooth, so it never mattered. But now that friction is actually messing up. So how to handle these kind of things? So let's take the rope on the curve there. So friction is acting only on that hemisphere. So take any small piece here at an angle theta. Consider a small piece d theta. So the small rope there. So I will just draw the picture like this. I'll just make it horizontal for convenience. I'm exaggerating the figure. It looks this big. It's a pretty small one. I'm just exaggerating the figure. So this angle will be d theta. There, that is that small piece. What are the forces acting on this small piece? We have tension. We will have tension T plus dt. So tension will keep changing. It will not be same everywhere. Why? Because there is a friction dF. Because of that small friction dF, the tension will increase by dt. So on both the sides of the rope, tension cannot be same. Due to the dF, small friction, the tension increases by dt. Now the dF can be right or left. We will do for one case and then we will extend it for the other case. Meaning on this small rope now, tensions would be of this sort. This will be T plus dt. Tension will increase by small amount and this will be T. So for each section dF will add up. That will increase the tension. This will be your normal reaction N on that small piece. Now a bit of a geometry here. If you drop the angles here, check out the angles. Remember, this tensions will be horizontal, so this is 90 degrees. If you take an half angle, this will be d theta by 2. So if that is d theta by 2, this angle will be d theta by 2. That will be 90 minus d theta by 2. This angle will be d theta by 2. Remember them, will be useful because this will come at least 6 times. Similarly for this tension also, t plus dt, if I use the same logic, d theta by 2. Again, see how I did this. This line and this line are parallel, so alternate angles. This angle will be d theta by 2. Then this angle will be 90 minus d theta by 2. These two are 90 degrees because it is a tangent. This will be d theta by 2. So with the horizontal, this angle will be d theta by 2. With the horizontal, this angle will be d theta by 2. And remember, d theta is very, very small angle. So you can resolve the forces into components. So the horizontal components will be how much? Let me write in the next page. But let's have a look at this picture. Any doubts on the angles, the geometry part? Great. Then this is t plus dt. So the components will be, this will be t plus dt cos d theta by 2. Because this angle was d theta by 2. T plus dt sine d theta by 2. There are a lot of small approximations in this. This is tension. This is friction. So this will be t cos d theta by 2. And this will be f cos d theta by 2. And this will be t plus. Actually, this will be very small friction. Let's not write it as an f also. Let's just take it as df. That will be t sine d theta by 2. We are not writing df because df is very small. Compared to this tensions, df is negligible. It will become like df into d theta. When you multiply two very small quantities, you get 10 to 0. We are ignoring that. And this is your normal reaction. So the normal reaction n will be t sine d theta by 2, t plus dt sine d theta by 2. For small angles, this is an approximation we use. For small theta, sine theta is approximately equal to theta. That is one approximation you need. Example, if I say sine 2 degrees, don't write 2, convert into radians. So this will be sine 2 pi by 180 radians. So that will be equal to pi by 90. Sine 2 is not 2. So for small angles, sine d theta by becomes d theta by 2 plus d theta by 2. This will become dt d theta by 2. Dt is very small, d theta is very small. So this becomes negligible. Since they're very, very small quantities. So from here we got normal reaction is T into d theta, where T is the tension of the rope at that instant and d theta is a small piece. A lot of work, I know. All clear the picture so far. Now in the horizontal direction, when you write the forces, you can take cos theta also, but understand cos d theta by 2 will be 1. Since d theta is very, very small, tends to 0, cos 0 will become 1. Whereas sin d theta by 2 becomes approximately d theta by 2. So for small angles, cos theta is 1 and sin theta is theta. You can do the same thing for tan theta also. So for horizontal, if you look at the forces, tension plus dF will be tension plus dt. dt will cancel. You end up with dF is equal to dt. But we know friction is always less than or equal to mu n. So you actually get a range there. So this will be dt less than equal to mu, but n is what? Just now we calculated t d theta. So we get dt by t is less than equal to mu d theta. Integrate on both sides. dt by dt is less than equal to integral mu d theta. So if you integrate this, on one side the limits will be f, the other side the limits will be mg. This will go from 0 to pi. So we get that will be ln t limits f to mg is less than equal to mu into pi. So I'll do one thing. Let me write it in terms of general form. If you take 0 to theta, and this side if you take it as f and mg, let's put pi, doesn't matter. This will be ln mg minus ln f. This is mu pi. Then I hope you know how to do logarithm. Send the exponential that side. We'll get mg by f is less than equal to e power mu pi. From here we get f must be greater than equal to mg into e power minus mu pi. Lot of work. Let me give you a more general result for this, more usable form. But you're getting what we did. I think if you understood this part, I think I'm more than happy. The remaining part is fine. You will understand over the course of time. But taking elements like this is the most important thing. I'll brief up the whole thing again. Listen once. So the first problem we are facing is when you have a rope on a rough cylinder, when it moves, there'll be friction between the rope and the cylinder. Because of this, you can get two possibilities. If the rope is going to the right, friction will be to the left. Rope is going to the right, friction will be to the right. So this F value can be less than mg or more than mg. Friction will provide the remaining force. So actually you get a range. Now what we did, since friction at every point is changing, so who is creating the normal reaction? Basically the rope ka tension is creating the normal reaction. And that normal reaction is creating the friction. So we took a small piece at some angle theta, d theta. But in order to see it more clearly, I drew it a big one here. You can see the forces acting will be tension on the right side, tension on the left side, and the friction. The reason tension is not same on both the sides is because of the small friction dF. Because of this dF, the friction increased by dt. So you can indirectly say dt is dF. That is what we got here. If you realize we got dt is equal to dF. But the problem is, how do I find the normal reaction? So I resolve the forces of tension, vertical direction, horizontal. The vertical components will create tension. This is where the headache starts because of approximations. Sin theta for small angles is theta. So you need to know that approximation. This is the first time you're seeing this, but pretty common approximation. You will see this in multiple chapters in physics. So learn that. So you are learning a lot of approximations in this. From here, we got the normal reaction. Then we got from here friction is dt, but we know friction must be less than equal to mu n. because it need not be maximum. And then we substitute it, and then it is math. This is one part of the value. If you take the friction in the other direction, because it can go both the ways, then the limits will be mg to f. It will reverse. Then you get f must be less than equal to mg into e power mu pi. So you get a range of this thing. So this is your maximum and that is your minimum. So your answer will be f ka value will lie between mg e power mu pi to mg e power minus mu pi. That would be your final answer. You'll get an exponential and integral and all this stuff. That's what happens if the rope has a friction. So we are lucky so far we never faced these kind of things, and generally these things are not, this is the borderline questions. They won't ask in mains. Advanced you can expect. So let me give you a more general result. Definitely try this again, check it out. It is lengthy, lot of maths involved and a lot of approximations and angles and stuff. So let me write a general result. Suppose if you have a thing like this, you need not have every time semicircle only. The rope can be anyway. So let's say rope is like this, making an angle theta. If someone is pulling this side with force F, and let's say someone is pulling this side with some F naught. And if you want to slide this rope, now see the rope can go left or right. The value will come out to be F1. Let's say if the rope is going this way. Or wait, I'll do something better. Let's say you kept a block of mass M here like this. Because of that range, yeah, it's a little messed up there. So we get two possibilities. If the rope is going this way, then the frictions will be backward. You'll get df, 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 all these frictions will act backward. In this case, you get the force on the maximum end. So you will get F1 max will be mg into e power mu theta. Suppose if it is sliding down, then frictions will be upward direction. That means your force will be less than mg. In this case, you will get F minimum will be mg into e power minus mu theta. That means your value will lie between mg e power mu theta, mg e power minus mu theta. And do you know how big is this value? This value can go to really high values. Just imagine you have a rope. Did you ever play tug of war? Must have played it. So imagine when you're playing tug of war and let's say there is a tree or a pole. So if you take a rope, you make it go around the pole, and then if you pull it, you know how much force should the other person apply to pull you out? Again, just listen. Let's say you and your friend are playing tug of war. So if you're playing like this straightforward, if I apply force F, you will get force F. But let's say you don't want to lose and you're playing like this. Instead of going like this, you'd make one loop and then your friend tries to pull you up. So if this person applies force F, right? Or if you apply force F, this person has to apply force F is equal to whatever you're applying, F into e power mu into 2 pi. Because you're making one full circle, the angle theta will be 2 pi. And let's say for calculation's sake, mu is equal to 0.2 or something. Then this value will be F is equal to e power mu, which is 0.2 into 2, and that is pi. Pi is around 3.14, that will be 3.126.8. So that is e power 0.8. How much is e power 0.8? It will be at least 2 times, I guess. So it comes to a pretty good value. So this will be at least he has to apply around 2.5 times the force. What if you make double loop? Once, twice, and then this thing. Then this will be e power mu into 4 pi. You're getting what is happening? Without doing any big effort, if you just make the number of loops more and more, it becomes very difficult to pull. That is the reason, if you ever see the ships, right, when they tie the ropes to the pillars, they tie like this. Do you ever see knots like this?
Yes.
You get a huge force here. Matlab, so if you take a rope like this and let's say you tie it 1 turn, 2 turns, 3 turns, 4 turns, and then let's say this block is attached to a pulley. So if you want to keep this block at rest, you need to apply very minimal force. So this FK value, so this is 4 turns. So the minimum force required to keep the block at rest, F minimum will be mg into e power minus mu into angle will be theta will be 4 times 2 pi. That is 8 pi. This is the minimum force required to keep the block at rest. That E ka value is around 2.7 something. Minus nahi aayega. E power 8 mu pi. Just imagine if you take mu ka value to be 1 by pi. For example, mu is 1 by pi, which is 1 by 3 roughly. You'll get e power 8. E power 8 you're getting. E power 8 is pretty big. How much is that? E square. I think around 54 times. So this thing would be mg by 54. Just imagine, you can keep a block of weight 50 kgs just by putting 1 kg ka weight. So you're actually using the friction can help to balance a lot of things. So this will be a minimum force. Vice versa, it is also difficult to pull the block. So the maximum force will be mg into e power mu 8 pi. So if mu is 1 by 3, it takes 54 times force to drag it. So either way, it is pretty advantage. E power 0.8 is 2.225 there. So the only problem with this, you know what? Eventually the force becomes so high, this stick will break. This pole will break, but the rope will not break. That is what will happen eventually. Is this thing clear, everyone? This is your general solution. So the more angle you keep it in contact, you get more force. Okay, e power 8 is 2981, it seems. Someone is calculating. That is 3000 times, everyone. So there, not even 50 times. Next time you try this and see. If you and 4 friends are playing the game, tell them this thing. You take the pole, you take the rope, make 3 turns, and tell 4 people to pull it. You will still win. Matlab, you can't win, but you can't lose also. So even if 4 people pull you, if you make 4 turns, they won't be able to pull the rope away from you. Clear with this? So what is happening, exactly? Every time you pull, you're increasing the tension. When you increase the tension, you're increasing the normal reaction. When you increase the normal reaction, you're increasing the friction. When you increase the friction, you're increasing the tension again. The function becomes, it's a positive increase. The function is just increasing itself. Is this thing clear, everyone? So how they'll frame a question, I'll ask you, tell me what will be the answer for this guy then. Same question, if I ask you like this side, if I keep a block of mass m1, this side you keep a block of mass m2. So we have a rough rope here. This is mu. Gravity is there. Find m1 by m2 for equilibrium. There, this is how they'll frame a question. If the pulley is smooth, it is 1:1. If the pulley is not smooth, you saw what will happen. What will be the answer for this? Find m1 by m2 for equilibrium. You just need to replace your f with m2g, isn't it? So there, basically the ratio will be this, m1 by m2 will be less than equal to e power mu pi e power minus mu pi. Clear with that? Just replace f2 with m2g and other m with m1g and you're done. It's the same question. So bring that mg down, you'll get f by mg is less than equal to e power mu theta and e power minus mu theta. This is how you can write this. It doesn't matter like what ratio you take, m1 by m2 or m2 by m1, it's the same thing. Clear with this? So as long as the ratio is between these two values, the system will remain at rest. Completely different than what you have done so far. Little weird. There are a lot of new things, a lot of approximations. Please make sure to go through this. You will encounter again something like this in circular motion. Next chapter. Clear with this? Take a break. Come back in 5 minutes. Any doubts on anything so far? Make sure to go through the whole thing. You will get confused somewhere. Do ask me in the next class at least. Okay, come back in 5 minutes. Yeah. Chal, cams on everyone. Let's see something little easy. We got a wall here. We got a floor here. We have a chain here. Which is like this. This length is L by 3. This point here is fixed. This angle is theta. So basically this is the boundary there. So that part of the chain is hanging in air and this part is L by 3. Gravity is there and the coefficient of friction is mu. Let's say mu is equal to let's let it be mu only. Mass of the chain is m, total length of the chain is L. Is they getting how is the picture? A part of the chain is hanging on the floor, remaining part is on the table. Find theta if the chain is about to slip. So every time you hear this word about to slip, right, meaning indirectly they're telling you friction is maximum. Because if I simply say it is not slipping, friction can be anything less than maximum, then it will become difficult to solve. Let's get this. Others cams on. Cos mu by 2, cos inverse 1 by 3. You got an answer without mu? Right, Siddesh? Right, Samyak? Answer comes in terms of mu, right? Let's see. Let's divide the thing into two FBDs. So let's cut off the piece here, one piece here and one part here. So when I draw the FBD of this hanging part of the chain, what are the forces? This will be some tension T2, this will be tension T1, and weight will be 2 mg by 3. Why? Because the total length is L, and on the floor there is an L by 3. So 12 by 3 will be on the air. This angle is theta. This angle is also theta. So this will be T2 cos theta. This will be T2 sin theta. So from here you can clearly see T2 cos theta is balancing the weight 2 mg by 3. T2 sin theta is balancing T1. Now if you look at the rope on the floor, the same tension T1 will act here. And you said it is about to slip, so this is F maximum. This is 1/3 of the chain, so the weight is mg by 3. This is the normal reaction. So here T1 will be F max. F max is nothing but mu into n is nothing but mg by 3. Therefore, if you divide this, you will get tan theta is equal to T1 by 2 mg by 3. But T1 is nothing but mu mg by 3. Mu by 2. There. Check it out. Are you clear with this? So divide the whole thing into two pieces. How are you guys getting cot inverse mu by 2? It should be cot inverse 2 by mu. Right, Utsa, that is fine. Tan inverse square. Tan inverse minus 2. What is that, right? Tan inverse mu by 2. Okay. Oh, power minus 1. Okay. All clear with this? Let's see one more. This is another good one. This is the top view. We have a conveyor belt going with a constant speed, 3 meters per second. You're seeing this from the top view, drone ka view. It is rough, so mu is 0.5. This is the width of the conveyor belt, whose value we don't know. You can treat along the conveyor belt as x-axis, perpendicular to the conveyor belt as y-axis. Now what you did, you took a coin and you projected with a speed of 4 meters per second perpendicular to the conveyor belt.
Sir, with respect to
Patience. If you wait for a few minutes, you'll understand. Patience. Why you guys become so excited? I didn't even finish the question. So a coin enters perpendicular to the velocity of the belt with 4 meters per second. So this is entering with respect to the ground. Meaning in the ground frame, it feels like it is going straight. Are you getting how it is? Think of like this. Matlab, the conveyor belt is going like this. Some person is running and trying to enter like this. It's like the man, trying to swim in a river. So what will happen? The conveyor belt will drag you this side, isn't it? So you are entering with 4 meters per second in the ground frame. So you are trying to go that way. Is the story clear, everyone? What is happening? The belt is going to the right and someone just hit a coin straight into it. If the conveyor belt was at rest, the coin would have gone straight. Now, because the conveyor belt is moving, it is going to mess up the coin. So the first question, find the minimum width of the belt so that the coin does not go to the other side. I don't want the coin to go and fall on the other side. You don't want it to cross the conveyor belt. Find the minimum width so that the coin does not cross the belt. In this process, find the minimum speed of the coin. During its entire motion. If it's a paragraph question, this will be the 2 advanced paragraph questions. First of all, is the story clear? Anyone didn't get the picture, didn't understand what is happening? Ask me that. Question is clear. Let's attempt the first one. Then let's go one at a time. So the belt is going with 3 meters per second, constant. The belt doesn't care about the coin. It's kind of like a river flowing, but this time there is a friction and all that stuff. The river problem was easy. The river would simply give you 3 meters per second, job's done. But this belt is not like that. The friction will come, and this friction is another stupid thing. Direction is not constant. Friction will be always opposite to the velocity. So it's little goofed up. Think. नहीं रे Siddhesh. Right, Arya. नहीं Samyak. If you got the first part, get the second part. I think Siddhesh, you got it, but you got something else. I asked you for width, you found something else. Now you got it, Siddhesh. Think. नहीं Shaurya. Now I'll give you a hint. See, the problem here is what is happening when it starts sliding on the belt. Because belt is also moving, friction will act something, it gets confusing. So let's do like this. Let's go and stand on the belt. I can do this. Why can I do this? Tell me one thing. Is the belt accelerating? Belt is not accelerating. Acceleration is 0. That means there'll be no pseudo force. So belt is also an inertial frame, isn't it? Since the belt is not accelerating, there is no pseudo force. So you can go and stand on the belt and solve the problem. That's not the answer. So let's do it in the belt ka frame. Let's see. So this is one thing, remember, if someone says something is going with constant velocity, that's a big clue. You can go and stand on that. Because since acceleration is 0, it is also an inertial frame. Since velocity of the belt is constant, acceleration is 0. Therefore, pseudo force is 0. If it was accelerating, it would have been a little pain. And remember this statement, friction is always opposite to the relative velocity. That is even better. So when I go and stand on the belt, what I get is relative velocity only. Friction is opposite to V relative. So actually problem becomes easy from there. So the moment I go and stand on the belt, so you're standing on the belt and looking at the problem. This is what you'll think about the coin. You will think this coin is entering with 4 meters per second. Remember, belt is going to the right side. So now you'll think the coin is going backward with 3 meters per second. So in your perspective, you will think the coin is actually going with 5 meters per second. This is velocity of the coin with respect to the belt. That means the friction should also act opposite to the velocity F max. Is that making sense? We know F max is equal to mu mg. This is equal to ma. So mass cancels off. We get A is equal to mu g. Mu is 0.5. So this is 5 meter per second square. That means this is what the coin will think. My speed is u. My speed is initial speed is 5 meters per second. This is u relative. My acceleration is also backward a relative, which is 5 meter per second square. So you don't want the coin to go to the other side. That means what? You want this coin to go here, and just to stop on this corner, isn't it? You want the coin to just stop on the boundary of the surface. Since you don't want it to cross the boundary, then you're done. Then you can apply v square minus u square is equal to 2as. So v will be 0, u will be 5 square, this will be 2, this will be minus 5, and this will be s. So s will be, 5 will cancel, we get 2.5 meters. But this is not the answer, because what you calculated is this distance. That diagonal, 2.5 meters. And you can clearly see from here, this angle will be 53 degrees. Tan theta 4/3. This is 53 degrees. What I'm asking you is to find the width. This will be the width. So tan 53 will be width by 2.5. Tan 53 is nothing but that is sine 53. Sine 53 is 4/5. So width will be 2 meters. Please check this. 2√11/25. Right, Utsa. Right, Ishman. Please check the first part. If you try to do this in the ground frame, it becomes very confusing because at every instant the velocity is changing, so friction ka direction will keep changing. Then I don't know how to handle this. But if I go and stand on the belt, my life becomes easy because belt mein there is no acceleration, there is no pseudo force. It's also an inertial frame. It is as good as standing on the ground. So if I go and stand on the belt, then I can find the relative velocity. The person will think the coin is going with 5 meters per second at an angle of 53 degrees. The belt behaves like a floor. the friction will provide an acceleration of 5 meters per second square backward. Your initial speed is 5, deceleration is 5. So you will travel 2.5 meters and stop. Why should it stop? Because you said you don't want to cross the belt, meaning you should just stop on the edge of the belt. From there I got S, but S is the diagonal. You want the width. So that will be 2.5 sine 53, which is 2 meters. Any doubts on this? Second part of the question. In this scenario, what is the minimum speed of the coin? Now, if you look at the scenario here, initially speed is 5. When the coin comes to rest, again, remember, this comes to rest with respect to belt. The coin really didn't come to rest. It is going with the belt ka speed, which is 3 meters per second. That means the coin starts with a speed of 5 meters per second, and eventually, this is how the motion will look, everyone. If you actually try to see in the ground frame, this coin will go something like this, something of this sort. It would go something like this, and eventually the coin will go with 3 meters per second. That will be the final speed of the coin. So somewhere in the middle, right, the speed actually becomes minimum, and that's not 3. What is the minimum speed of the coin? Right, Arya? How do we do that? The second part is actually more complex. First part is still manageable. Second part goes over the head. We'll see that. But think for a minute. Again, when you get a tough question, don't think like, oh, it's not a tough question. How will I know? Think the other way around. Good thing you saw it right now. You know how to handle this kind of things going ahead. That is how you learn. If you don't handle tough questions, and if you run away from tough questions, you will never learn. Yeah, minimize karna padega. But there is a way. Without doing any using maximum minima, you can figure it out. So you are asking for the minimum speed in the ground frame. So how do we do this? Question, there's nothing there. Find the minimum speed of the coin during its entire motion. नहीं सम्यक 12 to root में नहीं आएगा रे सम्यक. Let's see everyone. Again, let's see first of all the coin ka velocity in the belt ka frame. So when you're standing on the belt, the coin is initially going with a speed of 5 meters per second. The acceleration is also 5 meters per second square. That means as this coin is going like this, at some point, the velocity v will be v is equal to u plus at. This will be v is equal to 5 minus 5t. Remember, this is the velocity of the coin with respect to the belt. Belt thinks this is the speed at time t. Now we know velocity of the coin in the ground frame will be velocity of the coin with respect to the belt plus velocity of the belt with respect to the ground. So now here, if you are a little smart, how you take the quantities, your life becomes pretty easy. So we have to add these two things vectorially. So we have one vector like this, 5 minus 5t, and we have one vector like this, 3. So if I add these two quantities, my job's done. And this angle is 53 degrees. This is 53 degrees. Now how to choose your x and y axis? I'll show you the easy one first, and then I'll show you what happens if you take the standard one. take the directions perpendicular and along the coin ka direction. So you choose this as x and this is y. And you will see what happens. If that's 53, that is 53. So this components will be 3 cos 53. And this will be 3 sin 53. That means don't touch that 5 minus 5t. So this resultant will be in this direction. It will be 5 minus 5t. In this direction, it is 3 cos 53. Cos 53 is how much? 3 by 5. So, and this direction is 3 sin 53. So now velocity of the coin in the ground frame, there are two perpendicular directions. It will be magnitude root over 5 minus 5t minus 3 cos 53 square plus 3 sin 53 square. If a vector has two components, you can square them and add them. Now observe something clearly here. This value is always constant. This does not change with time. This is variable. So if you want the minimum speed, this has to be 0. Meaning you can adjust the value of time so that that term becomes 0. This has to be 0 for minimum speed. Therefore, so if that term becomes 0, V minimum is simply 3 sin 53. Sin 53 is 4 by 5, which is 12 by 5 meters per second, which is 2.4 meters per second. Is that making sense? What happens if I do it normally? If I take regular x and y axis? Let me show you that also. Because see, when you are adding a variable quantity which is changing with time and a constant 3, don't split that variable thing, because this is what will happen. See, if I try to do it regularly, 5 minus 5t and 3, this is 53 degrees. Then the resultant will be 5 minus 5t sin 53. This will be 3. This will be 5 minus 5t cos 53. This is also right, nothing wrong with this. So velocity of the coin in the ground frame, the speed will be root over 5 minus 5t cos 53, which is 4 by 3 by 5. I'll just leave it like this. Cos 53 minus 3 ka square plus 5 minus 5t sin 53 ka square. Did you see what happened? Both the terms have time. This is also variable, this is also variable. Both are changing with time. So now we have to do maximum minima. We have to do dv by dt is equal to 0, and then you have to solve further thing. Are you getting the problem with this? वो भी check करना पड़ेगा. Is this making sense, everyone? So it's more of a logic like, okay, see, because this 5 minus 5t is a variable. If you're splitting into two parts, what did you do? This is already messed up. When you split it, you messed up both the parts. You're getting this? But if you keep the 5 minus 5t as it is and just split the 3 ka quantity, now you can clearly see this number will never change. This guy, you can put whatever value you want. So it works out. The only one thing you have to make sure, if you see, the coin stops at 1 second. So we have to make sure this time is less than 1. I think that will come less than 1. Yeah, it comes less than 1. Is the question clear, everyone? Yeah, you can simplify this. You can simplify this, but you'll get time here, you'll get time here also. Then you have to do maximum minimum. Can be done, nothing wrong. थोड़ा और lengthy होगा, but it
तो
can be done.
sin स्क्वायर प्लस cos स्क्वायर 1 हो जाएगा दूसरे मिनट में.
नहीं रे God, you'll stuck with the 2t का term आ जाएगा एक.
ओके सर.
कर लो, मतलब हो जाएगा तो अच्छा है ना. It is fine. I'm just saying. See, still you have to do something, right? Here, so you can see and tell the answer, right? That's it. So how you divide is more convenient thing. Is this clear, everyone? Check it out. Whatever we did today, again, the last 2-3 problems, they are pretty solid ones. This one and that rope one. This one. This one is also pretty good one. This is fine. Next thing. Let's see. Another standard model. These are quite important. They come a lot, especially in mains. Let's say we have a 2 kg block. We have a 3 kg block. The ground is smooth. You're applying force F is equal to 4 newtons. This friction mu is 0.2. Find acceleration of the blocks and the friction between them. I'll do one thing with. Let's say the force is F. Find acceleration of blocks. And friction between them. Case 1, F is 4 newtons. Two problems. Case 2, F is 20 newtons. There, let's get both of them. So you kept a block on top of another block. You're applying force F on the top block. Friction between them is 0.2 and the ground is smooth. If you apply 4 newtons, what is the acceleration and the friction? If you apply 20 newtons, what is the acceleration and the friction? Think. Take a minute. Then I'll show you how to handle these problems. Okay, right, Siddesh. Right, Samyak. Ne, Shaurya. Ne, Ishwan. Ne, Shrihari. I know what you guys did. Let me tell you what you guys are doing. Listen, this is the most common way people do. Draw the FBD of the blocks. Standard process. 2 kg. F is equal to 4 newtons. This is friction. You said mu is 0.2. N is 20. So this is 0.2 into 20, which is 4 newtons. Take the 3 kg block. This is also F is equal to 4 newtons. There is no other horizontal force. So since this is 4 and 4, this acceleration is 0. This acceleration is 4 by 3. Just think about it. How weird is this? Getting it? This is pretty weird. I'm pulling the upper block and that block is not moving, but the block below is moving. Meaning, just imagine today in your house now, you have a dining table, right? Let's say on a dining table, you keep some water bottle or something and you are pulling the water bottle. Water bottle doesn't come, but the dining table moves. You have a ghost in the house, isn't it? Can you see how weird is that? I'm pulling the top block, that is not moving, but the bottom block is sliding. The problem with this thing is, tell me one thing, who told you F is maximum? The biggest mistake you did, you wrote F is equal to mu into N. Who told you? How do we know F is maximum? I told you multiple times, you should never write F is equal to mu N. You have to prove it is slipping and only then you can use it. So how do we solve this kind of problem? So listen to this standard process. Whenever you see two blocks, right, don't directly jump into an FBD. You have to start with an assumption. Now here, two things can happen. Both the blocks are slipping or both the blocks are going together. Do you agree? Either both the blocks are going together or both the blocks are slipping. Something is happening. We don't know what is happening. So listen how to do this. Assume always the moment you see two blocks, start with the statement assume. If you write anything else, it will be gone. Sometimes if you're lucky, you'll get an answer. Assume both the blocks are going together. So listen carefully. Okay, remember this is an assumption. So since both are going together, I'll treat them as one big block. 3 kg, 2 kg. You're applying force F is equal to 4 Newton. Acceleration is A. So we get acceleration is equal to 4 by 5 meters per second square. Great. Choose any one block. I will take the 3 kg block. On the 3 kg block, the friction is acting forward. Acceleration is A. F is equal to 3A, which is 3 into 4 by 5, which is 12 by 5, which is 2.4 newtons. What is this? Remember, I didn't use any mu n and everything. This is called required friction. So friction is telling you, boss, give me 2.4 newtons. Listen, this is what it is saying. It is saying, give me 2.4 newtons so that I can make your assumption right. What is my assumption? Both are going together. So friction is saying, if you want both of them to go together, give me 2.4 newtons. But how much can I give you? F max is 4 newtons. Since F required is less than F max, you're asking for 2.4, but I can give you 4. Means what? My assumption is right. Both the blocks are going together. And with what acceleration? 4 by 5. How much friction you want? Again, how much can I give you? 4. But how much are you asking? 2.4. So how much will I give? 2.4. So therefore, the answer is 4 by 5. They're going with 0.8 meters per second square. And the friction ka value is 2.4 newtons. It is not a 4. Are you clear, everyone, how we proceeded with this? You cannot directly write F max and start solving the problem. There is no guarantee they are slipping. So you have to start with an assumption, let them go together. Then you find the required friction. So friction is asking, give me 2.4 if they want to go together. Clear? But I can give you 4. So problem is solved. Question is over there. My assumption is right and friction is 2.4. What happens the other way around? Let's see the second case. This time you're giving 20 newtons. We are getting a feeling they will slip, but still. 2 kg, 3 kg. Let's say we're applying F is equal to 20. Same story. Assume both go together. Acceleration F is equal to 20. Acceleration is equal to 20 by 5, which is 4 meter per second square. You can choose any one block. This time I'll choose the 2 kg block, just like that. So this is F, which is 20. The friction will act backward. This is your acceleration. So 20 minus friction is equal to 2 into A. If you observe, I'm not using mu into N anywhere. 20 minus F, that will be 8. So we're getting F is equal to 12 newtons. This is your required friction. Friction is telling you, if you give me 12 newtons, I will make your assumption right. But F max is only 4. Since the requirement is more than what you're asking, I can't make the assumption right. Therefore, blocks are slipping. This is what will happen. Either the assumption is right or it is not right. But fine, then I'm happy. Blocks are slipping. Therefore, F is maximum. Now you proved F is maximum. Now whatever you did, everything was wrong. Forget about it. Again, start the new FBDs. Now we proved F is maximum. So F is 20. This is F max, which is 4. And let this acceleration be A1. So A1 will be 20 minus 4 by 2. which is 8 meters per second square. 3 kg block, this is also F max, which is 4. This acceleration is A2. A2 will be 4 by 3 meters per second square. That's your answer. Are you getting what is happening? If your assumption is right, question gets over there. If your assumption is wrong, that is also okay, because now you proved F is maximum. Draw the new FBDs and solve. You'll get the answer either way. Are these steps clear, everyone? You can do that. That also works. Srihari, you can do that also. Try and see. Clear with this? So in this question, I can add one more. Find F max so that blocks go together. Let you guys try this. So 4 newtons, they're going together. 20, they're slipping. That means somewhere in the middle, there is a borderline force. So what is that force where they're about to slide? That will be your third question. Let's get that. That was the PYQ. Numbers are different, but yeah. If 4 Newton, they're going together, and 20, they're slipping. That means somewhere in the middle, there is a force for which they are about to slip. How much is that? Okay, I don't know the answer. Let's see. Try. I'll give you 2 minutes. Find the maximum force so that the blocks go together. Pretty good model. Next class, when we catch up, right, we are going to do almost like 4 or 5 problems on this only. We will see different variations. We'll put 3 blocks also. What will happen if there are 3 blocks? What happens? Force changes with time. What if ground is rough? We'll do all that stuff. So 2 blocks are quite an important set of problems in friction. Anyone else? 8 and 4 by 3. What are you finding, Ray? I'm asking you maximum force. What did you even find? This is another question. Find the maximum force so that the blocks go together. Arya,
Yes, sir.
what did you find? तो कुछ तो type किया 8 and 4 by 3. Okay, that's the last answer क्या?
Yes, sir.
I got it now. Saw it now. क्या करना था B part, C part के लिए? Look at the other one. You want F max? The word itself tells you something. The blocks are about to slip. Means frictions are maximum. Therefore, F is max. So just write both the FBDs separately. 2 kg. F max, that will be 4. This is F and this is acceleration. This is 3 kg. This is also F max, which is 4. This is also acceleration. They're going together still. About to slip, matlab they're still going together. So this will be F minus 4 is equal to 2 into A. This will be 4 is equal to 3 into A. So we get A is equal to 4 by 3. Take this and substitute here. We get F is equal to 4 plus 2A, which is 4 plus 8 by 3. Therefore, F is equal to 20 by 3 newtons. This is the maximum, everyone. Anything more than this, they will slip. 6.66 something. Right, Siddesh? Clear with this? Any doubts on this? Let's see one more like this. You guys try this. I think if you got it, you get the hang of it. Let's say we have two blocks. For now, we'll keep the ground smooth. Next class, we'll make ground also rough. Let's say this is 5 kg and this is 3 kg. And you're applying F. Let's say this is mu is equal to 0.3. Let's say case 1, F is equal to 8 newtons. Case 2, F is equal to 40 newtons. Find acceleration and the friction between them. Same thing, I just changed the numbers and I kept the force down. Finish off, last one for the day. Again, remember the process. Assume both the blocks are going together. You have to start from there. You directly can't dump the FBD there. Okay, let's see. Okay, I think first is 1 and 3. Most of you got it, right? Let's see the first one. Five kg, 3 kg. You're applying F is equal to 8 Newton. Mu is equal to 0.3. Assume both the blocks go together. Then acceleration will be 1 meter per second square. Choose any one block. I'll choose a 3 kg block. The friction will be forward. Acceleration is 1. F is equal to 3 newtons. This is your required friction. F max is 0.3 into 30, 9 newtons. So your assumption is right. You're asking for 3 newtons, but I can give you 9. Therefore, the blocks go together with an acceleration of 1 meter per second square. And the friction is only 3 newtons. Clear with that? Same story, second one. This time you're applying 40 newtons. The number itself looks big. But yeah, if I give it 24 or 16, then there'll be always a confusion. Again, same story. Assume both are going together. I'm telling you again, you see two blocks and you start with assume both are going together. If you do anything else, there's a high chance you'll goof up. Most common mistake, people start writing Fmax without even thinking whether should I keep it or not. Then we get acceleration is 40 by 8. 5 meter per second square. Yeah, this definitely looks like it is gone. So if you take the 3 kg block, the F is equal to acceleration, F is equal to 3a, it is asking for 15 newtons. So gone. F max is 9. Therefore, blocks are slipping. So my assumption is wrong. That is fine. So whatever you did, everything is gone. You just forget about all this is wrong, then cancel it off. So you need to always check, first of all, whether they're going together or not. Fine, they're not going together. That is also good news. That means F is maximum. Then just draw the individual FBDs. So on 3 kg, we have F max, which is 9. So this acceleration will be 9 by 3, 3 meter per second square. On 5 kg, this is 40. This F max is 9, and this is their acceleration A2. A2 will be 40 minus 9 by 5. 31 by 5 meter per second square. Are the steps clear, everyone? Yeah, I think most of you got it. Right, Utsa. Right, Arya. Sidesh, Samyak, yeah. Are the steps clear, everyone? That is how you handle 2 block problems. So do have a look at this. Any doubts on this, ask me. Okay, that would be the last one for the day. So there, in total, we have done almost 18 questions. So please make sure to go through this. The next class, when we catch up, we will do few more variations of this, but next class, we will wrap up the chapter. We will do some 3 block problems also. We will see what happens with force changes with time. We will see more variations of this. And if time permits, we will start off with circular motion kind reduction also. But it is almost done. Chapter is almost there. So you can start solving the material, whatever it is they're doing, start doing it. Okay, with that, we'll wrap up for the day. So any doubts, anything, please stay back and ask. Also, you're free to leave. I hope everyone has given the test. The deadline is 11:30 today. So